So the last point I want to make on modeling cash flows and making business decisions is inflation. Don't ignore inflation. So a couple of points about inflation. As prices of things go up, your purchasing power goes down. That's fairly intuitive, right? Anticipated future inflation makes interest rates and discount rates go up. For example, you have an investment in a new widget machine. Cost today is $9,500. Widgets today sell for $15. Widget price in the future is expected to rise at an inflation rate of 4%. The nominal discount rate is 12%. So let's look at an analysis. We have the inflation rate, we have the widget price today, the discount rate, the equivalent real discount rate. This is 1 plus B4, which is our nominal rate, divided by 1 plus B2, which is the inflation rate, minus 1. So let's look at this. We have year 0, $9,500 investment. Year 1, 100 widgets we sell, $15.60. Nominally, we earn $1,560. Adjusted for inflation, so real cash flow is only $1,500. This is D9, right? The real number that we generate divided by 1 plus B2, the inflation rate, raised to the number of periods. So we see that here we have the anticipated nominal cash flow, and here we have the anticipated real cash flow in year 0 dollars. In both cases, the nominal cash flow discounted at the nominal discount rate and the real cash flow discounted at the real discount rate are the same number. This is interesting. But the nominal internal rate of return, that's the internal rate of return from column D, is 14%. But the real internal rate of return, which is the internal rate of return from column F, is only 10%. So let's discuss this. We have a nominal discount rate of 12%. The equivalent real discount rate is 7.69%. This is the calculation. The real discount rate is equal to 1 plus the nominal rate divided by 1 plus the inflation rate minus 1. This is how we get the 7.69%. Column C in that spreadsheet shows the anticipated widget price in each year, computed by the nominal price, which is the price today, times 1 plus the rate of inflation. Discounting these at 12% gives us our net present value of $778. This tells us do the project, but really you need to know real cash flows. So real cash flows is the nominal value divided by 1 plus the inflation rate. So discounting nominal cash flows at the nominal rate and discounting real cash flows at the real rate gives you the same net present value, which I showed right here. This is not the end of the story. Nominal cash flows in dollars at the time received. You're promised $100 in 3 years. The $100 is a promised nominal payment, not taking into consideration any inflation. Real cash flows, you're promised $100 in 3 years, but we have 4% inflation every year. Then the real anticipated cash flow in 3 years is only going to be $88.90, right? Because you've got to adjust that $100 for your purchasing power. Nominal interest rates quoted today for future nominal payments. So you borrow $1,000 for 1 year at 7%. Your nominal repayment is going to be $1,070. This payment is unrelated to the interest rate. 7% is a nominal rate. It applies no matter what the inflation rate is. The real interest rate is the key. Interest rate adjusted for changes in your purchasing power. You borrow $1,000 at 7% nominal, but you anticipate inflation of 3%. Then the inflation adjusted repayment is only $1,038. the real interest rate that you will pay is 3.88%, right? And this is the formula we looked at earlier. So if we see we have a lot of inflation, your payback is going to be less in real money. How much did you really earn on this project, right? So we have these nominal cash flows. You pay out, you collect 15% internal rate of return, but using CPI and adjusting your nominal cash flows for the rate of inflation, you can calculate your real internal rate of return as only 10%. So the relationship between nominal and real discount rates, this is called Fisher's equation. Note that the nominal rate is roughly equal to the real rate plus the rate of inflation. Thank you.